into the discussion. Most eat and educates tend to be a more interactive style. This one is a little bit difficult because I didn't ask anybody to come set up the 3D printer because that's a huge hassle. So we're going to talk about 3D printing for a little while. You're hopefully going to have dinner, and then we'll just have a discussion if you want to talk about anything else about 3D printing. So.
I can set up a 3D printer about.
No, I don't want that to happen because.
I'm gonna do it anyway.
Well, then you're welcome to. That's fine. Okay. All right. So we've got an itinerary. We're going to talk about educate, which is your normal eat and educate schedule. Education, which is not your normal eat and educate schedule, and then educate with a question mark, which is up to you. So the first part, we're going to talk about educate. I don't own a rep rap. I'm not part of the rep rap organization. Yeah, people here do own rep raps, so they're welcome to correct me. But we're going to talk about rep raps real quick. So when you discuss rep raps, we tend to do it in the context of. Does anyone want a seat?
Is the big fan out there?
Yeah.
I was going to turn it off.
Okay. All right. There are more seats around here. Yeah. Awesome. Perfect. Excellent. But we tend to talk about rep raps in the context of 3D printers. And from their own definition, that's not exactly what they are. They are whatever will get you another rep rap. But so far, that tends to fall into the realm of let's make FDM printers, which Matt Sanderson is displaying for us. So when you want to create a new rep rap with a rep rap, you have some components that you got to deal with. One of them is structure, which we're getting pretty good at because you can 3D print a lot of the joints. The next one is circuitry, which is a work in progress. The next one is motors, which is also a work in progress. And then you've also got to print your hot end, which is surprisingly difficult on a recursive level because you got to melt it to print it, then you got to melt it to print. Anyway, so that's in the pipes by somebody, I hope. I don't really know. In any event, once you've done that, you've gotten it down to the point where you can go to Home Depot and you can get all the components necessary to build this item. And you're very close to an entirely encapsulated solution, so that your rep wrap will actually generate an entire rep wrap for you. You add a couple wires, maybe a few holding pieces like bolts and nuts, and then you're good to go. Right now, we're to the point where you can get the electronics and the motors and a couple more vitamins, I guess, which are the long threaded screws, and create a rep wrap, which is really pretty cool. Yeah.
Do you know if there are any milling machines that fall into the rep wrap category? Because it seems like you could easily mill another mill.
There are PCB mills that fall into that. I got a picture from one of them, I think. But I don't know of any larger milling machines. I'm sure there are. I'm sure any mill that you build on your own would fall into that category because you can mill out parts to build another rep wrap. So currently, rep wrap is kind of taking a break while they focus on the commercialization aspect of these 3D printers. And so, I think this is great because a lot of the pioneers in the rep wrap community have started up businesses, and they're kind of tuning it to get it to market, get more people interested in 3D printing, make it more well known. And so this should carry us to a better public acceptance or acknowledgement of 3D printing or home manufacturing in general. But in the meantime, things like the guy who makes the J-heads, he's a little bit burnt out because of the Chinese clones, but those efforts to create an encapsulated solution where you can print the same item have cooled a little bit in recent years. Yeah, and so there are companies who have put a lot of effort into making the filament that we use and the items that go into the rep wraps, like the ramps kit and stepper motors. And I think that's great because that availability is a good thing. I think the more people in the community that we stoke the group with will add to the more people who can help solve these problems later down the road. But there are still people operating on the idea of printing a rep wrap with a rep wrap. This is a rep wrap Snappy, which was recently featured in Hackaday. It has the most printable frame of the rep wraps to date, and so you can actually print the scaffolding that you see in that GIF or GIF, and then snap it together and create the 3D printer, adding again the ramps kit, the motors, and the circuitry. So, to be really clear, I don't think that we should try to make or 3D printing a push-button solution like modern cars or like mini computer programs nowadays. Instead, I think that they should become more robust, and I think that part of RepRap is creating a more robust machine that falls into the general home manufacturing system. And so what we want is we want more science where people are figuring out like what filaments work better, what materials to print on work better, and what structures work better. And then we want to get to the point where the printers no longer require an insane amount of attention, which we all pretty much know about. And then serialization is just the next step, right? Like, because at the point where the printer operates pretty well on its own, like any other household appliance, you can then add the software to serialize. And the software's already there, pretty much. We just need to get the hardware to the same point. So I'm interested in serialization, and that's serialization in the point of printing continuously or having the printer print parts in a repetitious manner without you in the loop. I'm not talking about serialization in the point of like the firearms group serializing guns or something. I'm talking about the other one. And I don't know of a better word to describe it. So there's a little bit of collision there between serialization with numbers and serialization with printing parts on like a conveyor belt. So it's needed now, not later when we have the RepRap community up to date with the printers that can print more printers, because what I've noticed is that public schools are getting taken in for fools by people selling them 3D printers and not describing both the indebted cost that comes with them and the man time that it takes to run this 3D printer. And so schools will find themselves with either a printer or a fleet of printers and then have to dedicate a person full time to maintaining them, when often they can't also dedicate a person full time to IT or something else that's much more important in my mind. So we want to look at serialization as a way to help schools. Colleges don't count, they have TAs, so yeah. So the most obvious answer is this thing, which is gross and whatever. It uses a scissor lift to push the item off the print bed. It works for very specific items that are centered and large enough on the print bed, also durable enough to take falling to the floor. And the scissor lift aspect so far appears to work, but I happen to know from my class in robotics in high school that scissor lifts are a terrible idea and will never last. So we want to make the printer more robust, not doomed to failure. And so this is why I discount this idea. I didn't even try building one. But it was interesting to see people finally have a larger discussion on serializing 3D printers in the mainstream, like on Hackaday and on Thingiverse.
And it is funny.
It is hilarious. Yeah, I mean, cool. So that's neat. This guy posted back in, I think, 2010 that he had taken an i3 RepRap and he had added a steel plate right here to the end of the extruder. And when he was done printing, he would just run the steel plate across the print bed and pop the part off into a trash can below the desk. And he later posted another video several months later showing a set of these working in what looked like a stand-away garage. And he was printing fan shrouds for his own model of 3D printer that he was selling online. And that was the really only example I could find of serialization working in the wild, because he made it happen and he had videos, which is really neat. So Sanjay M's forum post was what got my mind ticking on maybe this could actually happen. It looked like he was maintaining it full time though, which is a detriment, but it's a step in the right direction, right? And so he credited the viability of this option to the idea that the i3 was very solid. And so you've got to have a really durable machine in order to just brute force the item off of the print bed after 5 minutes. So the next one is the New Valence robotics team, which became a company. They created this, which is a later model off of their prototype that also has a steel plate which pushes the part off of the hotbed into a bucket to the side so that you can take the part out. This one is designed for schools, which is really interesting. Unfortunately, it's proprietary, which is less interesting, but still good, right? Because if this takes off, then we're solving that problem, and maybe the RepRap community can follow suit later. Hi, Tyler. So, on that notion, I tried building a cheaper, more flimsy version of this on my printer bought Simple Metal. So we've got a little video of it trying to push a part off of the print bed. And the arm is plastic so that if the arm catches a part that doesn't want to move, the arm breaks, not the printer, which I severely like as an idea. And so it would do this crazy nonsense, and it would scan the print bed, right? And took forever. It worked surprisingly well, considering that I threw it together in about a week. I think this is a valuable idea. And I think with some more work and maybe a couple of plugins for Octoprint, it could become a thing. The problem is that it doesn't do anything for your robustness. The printer loses a little bit of robustness because, one, you have to be very accurate with this method. If you miss, you're going to run the thing into the print plate, or you're going to grind the gears against a part that won't come free. You also have to deal with the fact that if you use this, then you lose accuracy on the extruder. And I found that the extruder would become decalibrated every single time you ran it, and eventually it would just print poorly or in the wrong location on the print bed, which is a struggle that could be fixed and maybe could lead to this being used more widely. So there's this. We don't talk about this. This is what MakerBot designed, created, and immediately disposed of, thus taking it and its patents to the grave. You can build one of these off of files from Thingiverse. You cannot sell them because it's patented. The conveyor belt idea, in fact, is patented, which makes it very difficult to get around that. But the reason behind not building one is that the films that can work with this tend to deform or warp or bubble after a little bit of time on the hotbed. And so this conveyor belt is less durable as an idea because you have to be replacing the film every so often. I suppose that's why MakerBot got rid of it. They never said, though. You can't. There's a blog post in this link that talks about them releasing it in 2010. Then there's no blog post about them quietly getting rid of it. So we can only guess. And I guess that it's all the people complaining when they bought one that the film immediately stopped working for them. Because you can't have bubbles in your print bed. We know this. All right, so on to another idea. This one being a little bit less elegant, I guess. Let's see if we can use a bed of nails approach. The idea being that the part is stuck very well to your print bed. If you can somehow deform the print bed in a manner that pushes the part away from the majority of the surface, it would break free. And so when you simplify this idea so that it might possibly work, you end up with kind of a lever in the middle of the print bed, because the prints automatically center via software to the middle of the print bed. So you're pretty sure to get on one of the seams. If you move the lever, the print should come free. And we actually built this. I think several people from the shop helped with this endeavor, which it was. So you mill out a channel on an aluminum plate. You add this bar and a lever to a servo, which was all zip tied together. But anyway, it worked surprisingly well. Here's a shot of it actually printing something. I'm sorry that the plastic is blue on the blue bed, but that part then later was tilted by that bar and broke free. It worked pretty well until a point at which it ruined the hot end. And at that point, I kind of gave up on this as an idea, because I think that it is also viable, but only if someone with more resources or time or skill than I built it. You have to have it be absolutely flush with the print bed. When the lever is down, it has to actually sit completely flush. Otherwise, the hot end will ding into it every time it passes past it, thus deforming your 0.4 millimeter aperture, which is pretty easy to do on brass hot ends. So I think it could work. I think it's a lesser solution to the bulldozer approach, because if you get a piece of plastic underneath it, it won't settle down correctly. There's a little bit more mechanical questionableness because you're adding more mass to the print bed to shove around. So you have to put more current through the motors, which makes them louder, which is a big problem for me because it's in my room. And at the end of the day, you break the part free and then it's still on your print bed, which doesn't prepare the print bed for the next thing. So you could add maybe more structure into this, another servo, mechanical arm that would move the part off of the print bed, but I didn't, and I gave up, so there you have it. The next one is maybe if we took this idea and expanded it and added a hinge in the entire print bed, you wouldn't be able to get plastic stuck in that channel. It might be a little bit more durable. It may be able to work on parts that are smaller or larger, but it also has a lot more mechanical complexity. The biggest advantage to this would be that the channel would warp the print bed when you heat it up. So if you added a hotbed to your printer, the fact that you have a centimeter of aluminum and then a ½ centimeter channel and then a centimeter of aluminum means that the print bed would actually warp, which then gets to the point where it would bump into the hot end while you're trying to print and ruin the hot end. So that was a pretty bad situation. This may have fixed that. I didn't build one because it's rather complex. what we now use on that same printer bot is a borosilicate glass plate where you use the thermal expansion of the glass and the plastic to break the part free. So you start with, to build your heated glass build plate sandwich, you start with some cardboard or other insulating material. You add a silicon cooking pad to that, then your hot plate, a piece of metal for the inductive sensor, and then finally a 3mm borosilicate glass plate that you've cleaned pretty extensively. You clamp it down, you call it good. And there it is. So this works surprisingly well. I like it so far. It's got a couple of pitfalls. First of all, I had to ramp up the heated bed in order for it to work, which is not a great solution since we like not burning things down. And this is basically a gigantic resistor and a gigantic power supply by some means connected together. So also the borosilicate glass plate will deform when it heats, which means that you're going to have some prints that will fail because the printer will center the theoretical plane that it wants to calibrate against around the edges and then start printing in the middle. And if the middle is up to 1 millimeter higher, then suddenly you're not extruding any plastic at all, which is a problem. The induction sensor that comes with the printer doesn't work. This is less of a problem for rep reps. This is more of a problem for me because the printer bot doesn't actually have any allotments for a larger induction sensor. But with a larger induction sensor, you can see through the 3mm glass plate and you can still home the device, which is pretty nice. So with that in mind, that there are some possibilities for a serialized 3D printer, but I haven't gotten any of them really tuned yet. We're going to talk about the state of education as far as 3D printers in classrooms. I've been giving a couple talks at both Madison City and Huntsville City Schools K-12 classrooms. And even while I was in high school and middle school, I felt like this was a problem where they would say 21st century education, throw an iPad in your hand and be really happy with themselves. And tying that to a sense of technology savviness or understanding technology is bad, right? These things are designed to be very user-friendly. So if you can operate it, that's great. That means that the person who made it did a really good job. But understanding it and calling yourself tech savvy is a different story. And so I would like to see more of that in classrooms. The second part is that teachers have a lot of bad ideas. Like I said, the printers are being sold to them or being hawked to them, really, as far as I understand it, with little to any information or acknowledgement of the actual task involved with upkeeping the printer. There's also this thing, which is a makey. A teacher in Madison City Schools recently bought a set of them. They're about $100 a piece, and they broke immediately. They were very flimsy for something designed for a classroom. And so I'm particularly angry about that right now. Anyway, because I fixed them. But on the flip side of that makey is a set of headers that are soldered on surface mount. And so if you just look at it too hard, they fall off because it's a surface mount header. I've never seen that before. So, oh well. But we want more robust things in classrooms, but we do want more transparency to electronics in classrooms so that students can learn that the things that they're holding aren't magic. Because when you're growing up, it may be hard nowadays to tell that the item which displays video and cartoons and whatnot isn't magic. It's pretty compelling stuff. So when I was in high school and middle school, there were a couple of teachers who weren't quite hackers, but they supported me taking apart things. I'm not brilliant. I like taking things apart, but that's about the extent of it. And I think that there needs to be a push to make that more recognized in schools, even if there isn't particularly a person at the school who can be the hacker or the maker or the person who understands in some high degree technology, because at K-12 that's pretty specialized. But a general push for that to be accepted, right? So anyway, this is a thank you to those teachers. But because of them, I got to do things like build a backpack with 2 speakers and a car battery in it, which was great. And nobody questioned it, except for the occasional, oh my God, is that hydrochloric acid? But that's to the side point. Anyway, this was a lot of fun. I got to learn a lot about wiring things together and power conversions. There's also the high school robotics teams, which are an immense resource. This is run by someone who neither had a kid in these classes nor was a teacher. So you don't have to be particularly closely tied to the school system in order to help out. And this person devoted basically several months of his life to making this happen. and he had to negotiate with the rest of his family when he would and when he would not be 24/7 all about this competition. It was great. We learned a lot about programming and mechanicals and mechanical components. So between those two things, both ad hoc or extracurricular and the classes that were provided, I think that I got a pretty good deal out of it. I think that every student should have an opportunity. So I'm trying to create a website called Serial Box where we can make 3D printers available to schools without all the overhead. If you put the time in to learn how to use a 3D printer, you can then attach it later to this website and let people who want to investigate 3D printing print something or print a few things or test their design skills, because that's another aspect of 3D printing, and not have to go through the trials of actually purchasing an expensive device like a 3D printer or upkeeping it. This is also available to you. So as a member, you can log in with LDAP today, you can upload a part, you email me about it, and I'll print it for you. So this is a work in progress. I would really like your help. I don't really know how to scale web apps. It's a new experience for me. So this is a call for your participation right here. That's it. All right, awesome. And then finally, educate with a question mark. I think that people who frequent Makers Local are an excellent resource for schools. Whether you have a student in the school from your family or not, I encourage you to go out and to contact the schools to offer them a task or project or a course that you can give and see where that goes. Because people like you are going to be what makes more people like you from students, right? Otherwise, nobody will have any idea that you can actually take things apart, reprogram them, and put them back together. So I didn't actually get any permission to put someone's specific email address in this presentation, but you can go to the Huntsville City Schools website, look up their information technology section, and then contact them through that email address and see where that goes. You can also look up an enrichment, engineering, or programming teacher, reach out to them, ask if there's anything you can do to help, or offer them ideas. It doesn't have to be anything technical. In this picture, we had a class use Cheese Whiz and crackers to simulate an FDM printer, right? How closely can you mimic the printer? How precise does the printer have to be in order for it to design the object that you want it to? So you just want the gears to be turning, you want ideas to be put in place so that later they have the fundamental knowledge to get into this realm. And this is also a wireless robotic arm. So these iPads were kind of just sitting around the classroom, but with this, they can log in with the iPad and then drive it via a web page. And so they were playing with the task of pushing things around like a bulldozer with the robotic arm. So there are plans for building that online, and you can donate to a classroom for a couple $dozen. So that's all. Thanks for your attention.